Parkinson disease. Parkinson disease is a brain disorder that affects the way a person's body moves, like shaking, stiffness, and difficulty with balance and coordination. Diagnosis of Parkinson disease. Parkinson disease doesn't have any cure yet, so we try to diagnose the disease through other measures like blood tests, lab tests, and brain scans, but these tests are quite expensive and time consuming. That's why researchers have now started to analyze the voice sample. People with Parkinson's disease often have dysphonia, which causes reduced loudness, roughness, and exaggerated vocal features. We can find a pattern in the voice sample of people suffering from Parkinson's disease compared to from a normal person. While we analyze speech data from different sound recordings, we get to know the person is suffering from Parkinson or not. In simple words, voice analysis is cheap, easy, and non-invasive compared to other tests. There was a survey which was held in Istanbul University where 40 people were taken and 20 were those Parkinson's patients and 20 were healthy individuals. Each person was told to pronounce AOU 0 to 9 different words and 4 rhymed short sentences. And those voice samples were imported in paired software and 29 features were extracted from software directly which were related with pitch, shimmer, jitter, voice and harmonicity. Each person has 26 voice sample with 29 features each. Similarly, 40 people were taken in a survey and they have a total of 1040 voice sample with 29 features. Among the 29 features, only 26 are relevant for data analysis.
In order to gain a better understanding of our data, we will employ feature engineering in our project. First of all, feature engineering is an important stage in preparing data for data analysis. It is significant since it emphasizes the quality traits and also helps in the creation of accurate models and detects the hidden pattern in data. In this project, we will use one component of the feature engineering, which is we will be looking for the features with correlation and also we will be capturing their hidden data patterns. Each voice sample in our study comprises of 29 attributes, out of which the relevant ones are 26, and after going over each feature, we are able to add three new elements to our data. First is the pitch range, which is the distinction between the maximum and minimum pitch. Second is the pulse period deviation, which is the disparity between the number of pulses and number of periods. And the last one is voice break impact, which is 100 minus fraction of unvoiced frames multiplied by number of voice breaks. Now that we have a total of 29 salient features, we will use these features to conduct our statistical analysis. Now we will look forward to the objectives of this project, and there are two main objectives of the project, which are to determine the extent of prediction and to determine the salient features. While determining the extent of prediction, these are some factors our data depend on, and they are data quality, feature selection, model selection, and dataset size. And as the second objective is to determine the salient features, for this we will be looking forward to the variables that we have used in our prediction model, which are jitter, shimmer, harmonicity, pitch, pulse, and period.
Hi, my name is Nguyen, and now I'm going to tell you about the approach for diagnosing Parkinson's disease. And we're gonna use the two sample t-test because we need to find silent features. So we need to conduct a test to see if there is a big difference between the means of each feature. So the null hypothesis is the mean is equal, and the alternative hypothesis is the mean is different. So we will conduct the test for all 29 features here. And how we're going to prepare the data for this approach, we have two methods. The first method is to group all 26 rows into one row of a person by the mean, and we are going to repeat all the columns and all the other individuals by this line code. I'm going to write this code here. Here's the result. And the result, we will have 40 individuals and rows and 29 columns. We will need to divide into two tables, the first 20 rows of people for Parkinson dataset and the last 20 rows of people for non-Parkinson dataset by using this line of code. Here's the result. It's down to here. And the second method is to divide directly into two individuals without grouping into one person or one row. The first 520 rows are voice sample for Parkinson, and the last 520 rows, for example, is for non-Parkinson dataset. By using these two lines of code, we're not going to group by mean anymore. And here's the result. So the first method we can use to reduce the variability and to decrease the effect of variation between different voice samples of a subject. In summary, it can show variability between individuals, and it can be really beneficial for central limit theorem for inferential statistics like receipt test, t-test, and confidence interval.
In the second method, variability is larger. It will be straightforward. It will reflect the variability between the voice samples recordings, not the individuals. And this is the distribution of the features from the first method and second method. And finally, although the distribution from the first method do not seem to be normal as typical normal ones, but as the sample size here is not large enough, just 26, so if we have a larger sample size, the first method will be really beneficial for the mentioned purposes. We will be performing statistical analysis on each approach. We'll calculate mean, frequency and standard deviation of each group and then compare between the groups using t-stat and p-value. In our first approach, we get a total of 3 salient features, out of which one is created from feature engineering. The one with the least p-value was found to be degree of voice breaks, and the one with the highest p-value was found to be voice break impact. In our second approach, we get a total of 19 salient features, out of which 13 are created from feature engineering. The one with the least p-value was found to be absolute jitter in microsecond, while the one with the highest p-value was again voice break impact. We also have 10 features in second approach where they are almost useless to voice analysis. With this result, we can reject our null hypothesis where we state that there is no difference in the statistical voice analysis between the Parkinson patient and non-Parkinson patient. With the support of our alternate hypothesis, we can say that if a person has to be diagnosed for Parkinson's disease using voice analysis, we can diagnose using the salient features from our approach. There certainly are limitations to this approach because this dataset does not indicate about specific recordings. That is, it does not give details about the type of recordings on whether they come from vowels, numbers or sentences. So this limits us to explore the patterns that could be seen within the 26 voice samples themselves. But with our two approaches, we can definitely analyze the variability within the sample of individuals and between the sample of two groups. Thank you.